Thank you. So the good thing with being the last in this case is that a lot of things have been said already, so I can probably jump over some of what I was going to say here. Yes, correct.
You can also use this one if you want.
Yeah, we will see here which one. Perhaps I get something turning around then. So this is when the things were coming to Enköping, Hageby. This is a chicken farm where we were stationed the whole thing. And we were taking slaughtery waste from, and unfortunately we hadn't really thought about the logistic, because we wanted to have it at the farm, but the slaughtery was actually done inside Västerås. And then you had to take these materials from this slaughtery out to the farm, and we realized that probably something happened on the way during the transportation, because it was very hot in August and September, so we had got some decomposition of the easily degradable things on its way. Here is the team. You can see a lot of those, and I just ask my colleagues here to stand up. We have Patrick Klintenberg and Sebastian Schwede and Yuying Lee here, who were participating in these tests here. And we had also a number of students, our students participating in. Johan Lindmark, one of the PhD students, was like leading quite a lot of our experiments on site there. So the main substrate was slaughtery materials, and this is I think is the only ecological chicken farm in Sweden. Maybe that is one in the southern part of Sweden, but we think it's the only. So they are not using any toxics and things like that. So everything should be done, and they are producing their own food for the chickens. So all those type of things are included in this, for good and bad. But it's probably good from the perspective that you don't have chemicals that could be negative for later on for the microorganisms. We had too little glucose and those easily decomposable substances due to this transportation, which made it. We had a little difficulty to produce this 2,3-butanediol in the beginning, and then Elias said here we test. This was on a farm, so they had a lot of apples falling down to the ground. So took some of those apples and injected it, and there we have easily degradable things.
One afternoon we were peeling apples.
Yeah. Then we got production of this pentanoic acid and this valerianic acid here, and also 2,3-butanediol. Yes, we got afterwards tried to cool this slaughtery material to reduce the degradation and so on. So it was produced some, not in the beginning, but a bit later on during the processing. There was some, preserve the hydrolyzed waste. It was decomposing a bit too quickly. The initial mixture of amino acids and lipids still was is quite tough material from a different perspective for these biological processes, but it was converted into a number of very useful substances after some time here. And this is how the substrate looks like. You can see here the different type of species. It was substance of slaughterhouse waste, and then chicken manure, and we had also straw and sawdust that was injected, and everything principally from the surrounding here. So the glucose limitation was making it a bit difficult in the beginning to produce 2,3-butanediol, but we got a number of other things instead, and there was valeric acid, amyl substances, and pentanol. And we also had in the beginning a lot of hydrogen produced. It decreased later on. And we think it was transferred and absorbed to some extent in the amines and so on, and then you formed instead a lot of NH4 in the process. The bacteria used principally should be Clostridium and Klebsiella. In reality, it was mainly Clostridium acetobutyricum and Clostridium butyricum. And from those, we got the organic acids that we were talking about. we had no lactate formed as the lactobacillus were destroyed during the hygienization process. This valeric acid, pentanoic acid, has 2 to 3 times higher value than the 2,3-butanediol, and you could use it for perfumes and things like that. So that's nice here. What we can see is this is from 2 of the runs. You can see hydrogen was starting to form after you added potato, and then after adding sugars. So you can see a direct reaction on that. When you added the apples, it took some time, but then you got also there, but it was a bit longer time lag on it. When it comes to the run 4, we had manure sawdust, intestines, and blueberry soup also here, and some enzymes added. And you can see that 2 or 3-butanediol, when we were adding enzymes first time, nothing happened. Second time, it started increasing, and then with the blueberry soup, it increased a lot. Acetic acid, same situation. And propionic acid, the same situation there also. So you can see how it took off when you were adding those extra, the enzymes and these like glucose and nice substrates. So I think I was a bit too quick there, but then we have saved some few minutes.
Time for discussion.
Yes. So